Today, what we're going to learn how to do is to solve equations if they have a fraction or a decimal coefficient. So obviously, you can solve this equation by using the fractions if you want to, but I know many of you don't like to operate with fractions. So what I would do when I see an equation with all of these fractions is you look at all your denominators and you find your least common denominator. So in this case we have 3's and 4's, so my least common denominator would be a 12. So what I do is I multiply the entire equation by my least common denominator, which is 12, or if you want, 12 over 1. So I'm going to do 2/3 x times 12. So what I do is I think 12 divided by 3 is 4, and then times 2, which is 8x. And then 1/3 times 12 is going to be 4, which equals 3/4 times 12 is 9. So now you have a really easy two-step equation with whole numbers, and you're going to solve it the same way you have. So I'm going to start with my addition subtraction. So to get rid of a plus 4, I subtract 4 from both sides. So now I have 8x equals 5. And to get rid of the times 8, I'm going to divide both sides by 8. And I get x equals 5/8. Now, since I already have a reduced fraction, I'm going to leave my answer as a reduced fraction. I'm not going to change it into a decimal. And then, now that I have my solution, I'm of course going to go ahead and check it. So let's go ahead and check it. And so we're just going to plug 5/8 back in for x. So I have 2/3 times x, which is 5/8. So we'll put in 5/8 plus 1/3 should equal 3/4. So you're going to check it the exact same way you've been checking all of your equations. So here I have 2/3 times 5/8. I'm going to cross reduce a 2, make that a 1, and make this 8 a 4. So now I have 1 times 5 is 5 over 12 plus 1/3 should equal 3/4. Okay, and on this side, in order to add, I need to find the least common denominator, which is 12. So then this becomes 4/12 should equal 3/4. So now I have 5/4 plus 5/12 plus 4/12, which gives me 9/12 should equal 3/4. And if I reduce 9/12, I get 3/4, which equals 3/4. So I check. Okay, let's try another one. What I want you to do really quickly is I want you to pause the video and I want you to go ahead and try this example, and don't forget to always include your check. So go ahead and pause the video and do this one on your own and start it back up when you're done. Okay, so for this question, my least common denominator of 3 and 5 is going to be 15. So I'm going to multiply my entire problem by 15. So 1/3 r times 15 is going to give me 5r, minus 2/5 times 15 is going to give me 6, and then 2/3 times 15 is going to give me 10. So again, now I'm going to treat this like a normal two-step equation. So to get rid of the minus 6, I'm going to add 6 to both sides, and I get 5r equals 16. To get rid of the times 5, I'll divide both sides by 5, and I end up with r equals 16/5. Again, this is reduced, so I don't have to do anything with it, and I would definitely advise don't turn this one into a mixed number. Keep it as an improper fraction for your check. Okay, so let's go over and check the problem by plugging what our value for r back into the original equation. So I have 1/3 times, and instead of r, I'm going to put 16/5 minus 2/5 should equal 2/3. So here there's nothing I can cross reduce, so I just multiply straight across. So I end up with 16/15 minus 2/5 should equal 2/3. So I need a least common denominator, which is 15. So 16/15 minus, and if I change this to 15ths, I get 6/15 should equal, 2/3. 16 minus 6 is 10 over 15 should equal 2/3. And if I reduce 2/3 by dividing by 5, I get 2/3 equals 2/3. So I check. Okay, so if we're going to do these with fractions, obviously we're going to do these with decimals as well. So we're going to learn how to solve an equation that has decimal and whole number coefficients. Again, you can solve it straight by using the decimals, or you can get rid of your decimals. The way we get rid of the decimals is we look at every single number, and we pick the highest power of 10 that we need to multiply by to get rid of the decimals. So here I don't even need to do anything, but on this one I would need to multiply by 100 to get the decimal place to move 2 spaces. And this one I need to multiply by 10, so the 100 is still the highest power of 10, and this one I wouldn't have to multiply. So since the highest power of 10 is going to be 100, I'm going to multiply the entire equation by 100. So now I have 4 times 100. So I'm going to do the math over here. So 4 times 100 is 400 x minus, and if I do 0.48 times 100, I get 48, equals 0.8 times 100 equals 80x, plus, and then 4 times 100 again is 400. So now I have a two-step equation. So the first thing I'm going to do on this one is I'm going to go ahead and take this negative or minus 48 and get rid of it by adding 48 to both sides. So that 48 goes, and I'm left with 400x equals 80x plus 448. Now, since I have my x's on this side and my constants on this side, I'm going to move this x over to the other by subtracting it. So now I have 320x equals 448. So then I'm going to divide 320 on both sides. So I get x equals 448 divided by 320. And since your question is given with decimals, what you can do is you can give me a decimal answer. So 448 divided by 320 is 1.4. So my x equals 1.4. So, of course, we're going to have to turn around and check it by plugging our value for x back into the original equation. So I'm going to start with my original equation, which is 4 times x. So I have 4 times, and for x we're going to put in 1.4 minus 0.48 equals 0.8 times x, which is 1.4 plus 4. So here now I have 1.4 times 4, which gives me 5.6 minus 0.48 equals, and then 0.8 times 1.4 is 1.12. So I have 1.12 plus 4. So 5.6 minus 0.48 is going to give me 5.12. And then 4 plus 1.12 is going to give me 5.12. So I check. And you can use a calculator for these equations, which I'm sure many of you guys will be very happy about. Okay, so next, let's go ahead and you can try one on your own. So again, I want you to pause this video and stop and do this one on your own by changing your, getting rid of your decimal coefficients. Okay, so let's go ahead and solve this one. So again, first thing I have to do is I have to figure out what I'm going to multiply everything by. And obviously my biggest power of 10, my largest power of 10 that I'm going to have to multiply to move all my decimals, to get rid of all my decimals, is going to be 100. Because here I need to move my decimal 2 spaces to the right, and the rest are less than that. So I'm going to go ahead and multiply my entire equation by 100. So this is going to give me 25d plus 0.1 times 100 is 10 equals 0.3 times 100 is going to give me 30d minus 0.4 times 100 is going to give me 40. So what I'm going to do is I'm going to move this 40 over to this side because I like keeping my coefficients positive. So I'm going to add 40 to both sides. And on this side I'm left with 25d plus 50 equals 30d. Okay, and now I'm going to move this d to this side because I want all my variables over here. So I'm going to subtract 25d from both sides. And I'm left with 50 equals 5d. I'm going to divide both sides by 5. And I get d equals 10. So again, I'm going to have to check it by plugging my value for d back into the original equation. So I have 0.25 times d, which we got 10, plus 0.1 equals 0.3 times d, which is 10, minus 0.4. So if I do 25 times d, what I'm going to get, or I'm sorry, times 10 is 2.5 plus, and then I have 0.1 equals 3.3 times 10 is 3 minus 0.4. So 0.25 plus 0.1 is 2.6, which equals, and then 3 minus 0.4 is 2.6. So we check. Okay, the other thing that we need to discuss today is, other than fractional and decimal coefficients, is we have two special types of equations. We have an equation with no solution, and we have equations with all real numbers as a solution. So this is going to be an example of an equation with no solution. So you're going to go ahead and you are going to solve it just like you solve any multi-step equation. So the first thing I'm going to do is I'm going to distribute on both sides. So using the distributive property, I get 3x minus 12, and then plus x plus 2 equals, and then 6x, and then I'm going to distribute them negative 2, so minus 2x minus 6. So next I'm going to combine like terms on both sides. So on my left side I end up with 4x, and then minus 12, negative 12 plus 2 is negative 10, which equals, and then 6x and a negative 2x gives me 4x, and then minus 6. Okay, what I can see already is that the 4x's are equal, and so if I were to subtract 4x from both sides, they would cancel out, and I'd be left with negative 10 equals negative 6, which is an untrue statement, and it can never be true. So I can stop here, and I can already see, because my 4x's, my variables are exactly the same, but my constants are not the same, I can already stop and see that this is going to be a no solution. So no value I plug in for x will ever make this a true statement. Or if you keep going and you say, okay, I'm going to subtract, let's say we go ahead and subtract the 4x from both sides, then I'm left with negative 10 equals negative 6, which again, not true statement. And so what this means is there is no solution. So what we expect you to write on a test is no solution. So no value for x will ever make this a true equation. Okay. The other type of special equation we have is an equation with infinite solutions, or in other words, any value that I plug in for x is going to make this a true statement. So again, I'm going to start it by simplifying my equation. So I'll do the distributive property. So I have 3x plus 6 minus 5x plus 15 equals, and then negative 2x plus 21. So on this side I need to simplify by combining like terms. So 3x plus negative 5x gives me a negative 2x. 6 plus 15 is positive 21. And then on the other side I have the exact same thing. So in other words, I can look at this and see my variable terms are identical, and so are my constants. So in other words, I could plug in any number for x. I could plug in 0 for x, and I'd get 21 equals 21. I could plug in 1 for x, and I would get 19 equals 19. So in other words, any value I plug in for x is going to make this a true statement because they are identical to each other. They are equal statements. So again, we could stop here and say there are infinite solutions, or every x will work. Or if you went ahead and kept trying to solve this, you would see that you would get, like, let's say if you added 2x to both sides, you would end up with 21 equals 21, which is always a true statement. So what we would say here is there are infinite solutions because every single value I plug in would make this a true statement. So make sure you watch out for those two special types of equations.